Hello, everyone. Welcome back to another Guideline Geo webinar. Today is all about Res2DInv and particularly the recent updates released with version 5. Since version 5 was first released, there have been a few additional updates. So today's demonstration will be working with version 5.02. Please be aware this meeting will be recorded and posted to our Guideline Geo YouTube account for future reference. And if you have any questions during the presentation, please add them to the chat and we will try to answer those at the end. So in this session, we will look at some of the ways the most recent Res2DInv differs from the legacy version 4.10 and earlier. We will look at the new features and apply the workflow using an example dataset. And this is a particularly interesting opportunity to talk about this software because I'm sure, like many of you, Res2DInv has been a staple piece of geophysical software for a long time. And I remember working with Res2DInv back in university and ever since. So it's really a pleasure to be able to talk about these updates today. So today we'll just begin with a few updates and give a few introductions. Talk briefly about the concept of inversion, discuss the typical workflow for resistivity imaging, and then go into our live demonstration of Res2DInv, where we will have the opportunity to explore and to talk about the new features. It will be a relatively short presentation, about half an hour of demonstration. And just to introduce myself, my name is Harry Higgs, and I am an application engineer here at Guideline Geo. I studied my degree in geophysical sciences in the UK at the University of Leeds, and then subsequently worked in industry as a near-surface geophysicist in engineering and ground investigation sectors. I joined Guideline Geo in 2021 as an application engineer, where my main job role is to provide training along with sales and technical support for ABEM product lines within the EMEA area. And here at Guideline Geo, we manufacture geophysical instruments and software and provide support services for subsurface investigations. We have two brands, ABEM producing resistivity, seismic and TEM instruments, and Mala producing ground penetrating radar instruments. We are a global company with a network of distributors covering more than 80 countries. And we have a business which started in 1923, making this year our centenary year. And to introduce the star of the show, Res2DInv, this is a software owned by Sequent as of 2021. Res2DInv is primarily a tool for inversion of resistivity and induced polarization data. So that's to say it takes our raw resistance measurements or apparent resistivity measurements, and it applies the process of tomographic inversion to calculate a model of the true subsurface resistivity distribution. And from those models, we can then begin to make geological interpretations. And any model produced from inversion is non-unique, meaning that there are alternative models that will fit the data. However, the better the quality of data going into the model, the more reliable generally the outputted model is going to be. So to obtain a model that is a true reflection of the subsurface we are measuring over, then we often need to do some data processing, such as filtering of bad data, and Res2DInv provides tools to do this. And as you will see, these tools have been expanded upon in this version 5 update. And then for relaying the information contained in our models in a way that is quick and easy to understand, Res2DInv provides a series of presentation tools, which range from various ways to grid your data, through to side-by-side comparisons with other data sets, through to visualization of 2D models in a 3D workspace. And today we'll see how the speed of inversion and the adjustments and visualization of models from pre to post inversion have been improved, along with options for filtering and navigation of the software menus themselves. So really, we'll see how improvements have been made all across the workflow from beginning to end. So I just introduced the concept of inversion using a 1D example. We often use the term inversion, and this is how we move from apparent resistivity to a final model of the ground's true resistivity. So apparent resistivity refers to the measurements from the surface and is the result of the current traveling along a path through different materials, rather than being the response from a single point within the ground. Inversion software takes our measured data. In this example, this is an apparent resistivity curve, and it creates a starting model of ground resistivities. The software carries out a synthetic survey identical to the real-world electrode arrangement over that model, and then compares the apparent resistivity curve produced by those conditions with the real-world recorded data. And if the two curves match to within a specified tolerance, the software will stop. And if the curves do not match, then the software will change the resistivity model, and it will run another synthetic survey and again compare the data sets. And this process is repeated until the curves match within tolerance or the specified maximum number of iterations. So that's the number of attempts to match the models has then been reached. And at the end of the inversion, the software provides a residual value, which is an indication of how well the modeled and the real-world data are matching. So how does a typical resistivity imaging workflow look? First, we collect many measurements using a resistivity instrument. Typically, we have many electrodes along a line connected with multi-core imaging cables to a switch matrix within the resistivity instrument. The instrument chooses different electrode configurations to inject current and measure voltage according to a predefined list called a protocol that's stored within the instrument. And this typically results in a data set with hundreds of individual resistance measurements, with each measurement having a high sensitivity over a particular region of the subsurface. We then take those measurements and do quality control. We check our electrode geometry is correct. Perhaps we merge our data with topography data, and we check the data quality itself. We can do this in Res2DInv, and we can also do this in Terameter LS Toolbox. Today, we are looking at filtering only in Res2DInv, but if you're a Terameter LS user, then we can also recommend that Toolbox is also a useful part of your workflow going forwards. And the reason is that the Terameter records a lot of additional information, metadata such as transmitter and receiver settings, data collection log, GPS information, electrode test results, and potentially full waveform data. And all of these data streams, along with detailed information on the measurements themselves, such as the measured voltage, variability of the recorded signal over the measurement cycle, the battery status during measurement, amongst other information, can be invaluable for data QC and also provide informed filtering choices and flexibility on filtering parameters. And we have to remember that the .dat file that goes into Res2DInv contains more limited information and is exported directly from your Terameter. So typically the measured resistance or apparent resistivity values, the array geometry, and the topography. So personally, I like to use Toolbox for an initial QC and filtering, and then I use Res2DInv to check the filtering as performed in the way that I wanted it to, and to make sure that there are no spikes in the data, and check where in the model pseudo section data points have been removed from. And this is a really nice tool in Res2DInv because then I can assess if the filtering has been too aggressive, for example, by leaving regions of the model without data points, or if the filtering has removed data points fairly evenly across the model. And I can then use this to adjust filtering as needed. And we'll see also that in Res2DInv, it has some really improved tools and workflow for filtering data in version 5. So next we select our model parameters in Res2DInv. The effect of changing model parameters, such as altering model discretization, is now shown on the fly. So you'll be able to see your model synchronized with topography data and updated to reflect changes that you make in the model settings. Next, we run the inversion. We now have benefit from a noticeably faster inversion and a graphical output of the misfit plotted against the number of iterations. So once we've run our inversion, we can then grid the model and analyze the results. So in Res2DInv version 5, we have lots of new tools to compare, view, and grid data in different ways. When we are deciding if we approve of the model, typically we might ask ourselves a few questions, such as, has a good fit been achieved? So what's the percentage difference between the real data and the modeled pseudo section? And are the results how I expect them to be? Typically, we'll have some idea of what we're trying to map and the range of values that are sensible, and perhaps even the distribution of the values that should be sensible for that geological environment, and whether those are realistic or not. So if the answer is no, then we can go back very simply in version 5 and change some of the starting settings and then just reinvert the data. And then once we're happy with the final model, we can then move on to the final step of exporting our models and our data. So now I'm going to jump straight into the worked example in Res2DInv. Okay, so should all be able to see my screen now, Res2DInv. It now uses a new licensing system where the licenses are registered to an organization and then checked out whilst using the software. And then once you've finished using it, it can then be checked back into its online repository. When we first open Res2DInv version 5, what we first will notice is that the layout has been completely updated. It's important to say that the inversion code is the same as previous Res2DInv version 4.10 and slightly earlier. The primary differences are in the layout, the data handling, and the data visualization. Firstly, in terms of the navigation, so all the menus are now navigatable within the main program window. So those can be seen up here. We have a series of tabs that you can flick between, and they follow the workflow quite nicely. So you might remember that in version 4, entering menus required opening pop-up windows. So the result of these changes is a quicker, more efficient navigation in Res2DInv version 5. So now we'll load some test data and look at the filtering and visualization of the pseudo section. So immediately we're presented with our data view on the top here and our measured apparent pseudo section below it. The data view is similar to the exterminate bad datum point menu from version 4 and older. However, the focus depths are now colored by depth groupings, and we can use the focus depths tab to turn these groupings on and off. So focus depth tab is here in the menus on the left, I flick over to this Focus Depths tab, we can then turn groupings on and off. And if we want to recolor them, we can do. And in the plot settings, we can switch between the display property, in this case, resistivity or conductivity. If we had IP, we could select IP as well. And you'll see that that automatically updates the pseudo section as well. And we can adjust the color theme here if we want to. There's a few options available there. We can choose to show lines or just discrete data points. And we have this curve factor as well, which adds some vertical exaggeration to the differences between adjacent data points. So if I lower that number, you see it accentuates the vertical scaling. And if I increase that number, it flattens it out more. So depending on the noisiness of your data set, you may want to adjust that setting as well, which I believe is new. We can also change the visualization of our pseudo section. We can have auto scaling of the colors. We can change the color scale itself, and we can choose what we want to show on there as well. And we can change the display type to discrete focus points if we want, and change the size of those. And finally, in the processing tab here, we can turn on and off point values by a range of values. So we can actually isolate a range of points based on their value, minimum and maximum here, and then apply. And the other thing we can do is we can make manual edits here using the mouse. And there's also now keyboard shortcuts that we can use. So for example, we can select a region of points and then disable them, either using the disable button, which is here, or use the keyboard shortcut Q and enable them again with the keyboard shortcut A. So at the moment, select points is highlighted in a rectangular pattern. So I can select all of these, and I can either press disable here, or I can press Q. And you see that that also updates the modeled pseudo section. The pseudo section. And if I press A, that brings them back. We can also select electrodes. So this is a new thing. If we highlight select electrode, we can highlight all of the data points that are associated with that particular electrode. So if we have a bad electrode contact, we might have a series of bad measurements associated with it. And this option allows us to easily isolate and remove those bad measurements. And if we want to isolate multiple electrodes, then we can hold the control key and we can select multiple electrodes within our profile like so. And then again, we can just use the keyboard shortcuts to remove those data points. And then lastly, we can zoom in on sections of our data profile and our pseudo section. And then we can pan around independently to look at different sections. So overall, the data tab, it now gives us a lot of freedom to manipulate our data and be also more precise with our filtering. So the next step in our workflow just follows the tabs on the ribbon. So we can just move across now to our Inversion tab. And this is another menu that's been improved. So we now see our model with topography applied by default. On the left-hand side, we have the settings menu where we can choose our model parameters. And if we want to know more about a particular setting, then we can just highlight a setting in the box, and below, down here, we'll see some text providing a description of the setting. Or we can just press F1 to open the wiki page. So for example, if we want to add model refinement to this model, we just go to the horizontal discretization, and then we select model refinement and change this to 0.5. And then we update our model grid. So if I click off here and press update, then we now see this updated. If we go to the info tab, then we now have some information about the model itself. So the number of data points, the number of model blocks, etc., etc. And then finally, if we go back to our settings, we can revert any changes by selecting the default settings and then update. And then that just removes any settings that have been applied during this session and just reverts back to the default model. And we can also load or save inversion settings. So for example, if we have a particular site that requires a similar set of inversion parameters, then we might save some for a particular site, and then we can load them up for each data set that we work on. So I'm just going to run this on default settings. So I just press run inversion here. So when we are running the inversion, the software shows each new model as it iterates. And the inversion time is now much faster. I did a few experiments with small data sets, and I averaged close to 50% time saving on small data sets for the actual time it took to run the inversion. It was really quite impressive. So the software also plots a graph of the RMS misfit as it changes with each new iteration for both the resistivity, and if we're running IP, then IP as well will be graphed in a different color. The RMS error plot makes it, I think, visually simple to see how misfit is changing over successive iterations, and the inversion optimization makes the workflow faster overall. And up here on the top left, what we see is we have a log of the inversion as it proceeds. So now the inversion is completed, and you'll see it automatically draws us into the next tab along, the results and model tab. And here the model is shown automatically with topography included. We can display contour data or modeled blocks. So in the model down here, display type is contour by default, but we can switch that to model blocks if we like. And we also have new display options here, including HSI. So that's accessed from the color scales here in general. And we can just press edit. So our base colors, we have the RGB, so the traditional colors that we have with older versions of Res2DInv. There's this hue saturation intensity option here, and both options can be applied with a discrete color bar, or you can change the discretization to a smooth color bar for both options. So I can apply this, and we are also given a histogram of the distribution of our data points, which makes it easy to then select an appropriate range for our color bar to perform over. So we can also step back through our iterations really simply. Just up here on the ribbon, we have this iteration number. So we can just step back through iterations or use the drop down. Perhaps if we want to go back to our first one and then step forwards. We can also step through time lapse if we have a time-lapse data set very easily. On the pseudo section, of course, we can toggle our contours and our values like so. And up here on the top right, we have the error statistics, which are familiar from previous Res2DInv. So here we can remove data points from the pseudo section based on their achieved fit to the model. So for example, we just click where along here we want to remove from. Then press OK. And if we go back in here, you see there's a now grayed out. And if we zoom in on our model, the positions with that have been removed are now shown as gray on the apparent pseudo section. So once we've removed points, then we just save that edited file. It appends the data as an _ed to show that it's been filtered. And if we go back and re-invert our data, we don't need to reload the data. You can just go back to the Inversion tab and then re-invert it. And when we're looking at our models as well and stepping through the iterations, we can also use the inversion info to look at the misfit and use that to guide us. So next we'll look at the compare tab. So this allows the comparison of different aspects of the same data set or different data sets. For example, we might plot from the same data set, resistivity and sensitivity together and use this to assess our model. Or we might compare different data sets that were gathered on the same site and then grid them on the same color scale. So we can compare different characteristics of the same data set by right-clicking on the active model and selecting clone, and then change the display using the left-hand menu. So I have a couple of files here with global coordinates applied. So I'm going to open both of these. And these are two different data sets collected at a crossroads that intersect, but they are not the same data set. However, if I wanted to compare different aspects of the same data set, I just right-click on one of them and then clone it. And then we see it creates another in the model view by default, but then here on the right-hand side, I can change any aspect of the display. So resistivity, I could show conductivity, the IP, sensitivity, uncertainty, or different parameters if we calculated them in the model. And it can also change whether I'm showing the model, the pseudo section, measured or calculated. And also which iteration number I want to show. And then I can remove it just with a right click. But what we have here are two lines collected at the same site of different data. So I want to compare both of these together. And I would like to look at them using fence diagrams in a 3D work environment. So the first thing I want to do here is grid them on the same color scale. So as we saw in the model tab, that's quite easy to do. We just select color scale, edit. I'll use smooth. Then do the same for the second one. Okay. And then to add these to our 3D view, we can just right click and add to 3D viewer one at a time. So here's one, and then right click on the second one, add to 3D viewer, and we see that they're both added. Now these aren't lining up as well as I'd like. So what I'm going to do is close this, press clear to clear the data from the memory. And then you'll see that here we have one that's run to 8 iterations and one that's run to only 4, but I'm going to go back to a slightly earlier iteration. Perhaps we've overfitted our model slightly. And then if I add those again, we can have a look and see if that's maybe a better match. Yeah, maybe a little bit. So it's a really nice way to view the data. So we can use this to help with interpretation or for presentation purposes. And if we have a GeoTIFF, then we can add that for background mapping as well for better display and contextualizing of our data. So that leads us on to our data export. There's other functions in here, but I just wanted to give you a brief overview of the operation and the main features. There's more to explore for sure. So we just, for data export, it's similar to the previous version. So we can go to export here, and we have our familiar exports for the data for AGS, XYZ, VTK, Geosoft, GPD, and Surfer. Or we can print our plots .png image files from here, or from our compare tabs if we would rather. So that brings us to the end of this demonstration. I'm going to just jump back into the PowerPoint. Okay. So just to give a summary, Res2DInv 5 provides us with an intuitive user interface. A faster workflow. And it also gives us new tools for data processing and visualization. I think it does a really nice job of presenting these features in a user-friendly way. Many of you will be perhaps very accustomed to the older user interface, but I hope this demonstration shows the advantages of the new layout and the features. And of course, I can't recommend enough the webinars provided by Kenny and Knud at Sequent. If you haven't already watched them, much of the content here reflects the information contained within those webinars. And in those webinars, there's also some additional discussion about the current limitations and the future development of that software, which I won't go into. So I hope you've enjoyed the presentation. I'd like to thank you all for joining today and for listening. And if you do have any questions, please enter them into the chat and I will stay online for a little while and try to answer them. But otherwise, I hope you have a great day and thanks again for listening.